Hello. So we are about to talk about honeypots in cloud security. My name is Daniel Bote, and this project is actually an implementation strategy for 4I security. So first of all, we'd like to talk about some of the recent developments in honeypot technology. Talk about the new tools and capabilities. So yes, first of all, we see that one of the new tools in the honeypot technology is advanced threat detection and response. So what this has actually done is to improve incident incident response capability through automated threat analysis and alerting. It has also enhanced threat intelligence gathering and sharing. This is something that has actually revolutionized the network aspect of the cloud. Also, it has integrated with existing security systems such as IEMS and IDS. So second, we have artificial intelligence and machine learning integration. So this has actually used AI and then the machine learning algorithm to actually analyze traffic patterns and also detect anomalies. So I think I skipped talking about honeypots. Let me quickly brush through what the honeypot is. So honeypot is actually kind of a trap that that attracts attackers. It makes them think that is a real network, but that isn't it. So it's kind of a trap, as I said earlier. Yes. So now let me come back to where I left. So I was at artificial intelligence and machine learning integration. So as I said earlier, honeypots actually now uses the artificial intelligence and machine learning algorithm to actually analyze traffic patterns and detect anomalies in the system. It has also enhanced incident response through predictive analysis. So anytime there is an anomaly, yes, sorry for that, it actually learns from that so that the next time that threat occurs, it can find a way of trying to curb it using the ideas learned previous. So our next point here is cloud-based honeypot solutions. Yes, so as we all know, cloud are actually scalable. So scalable and flexible honeypot deployment in cloud environments. Yes. It has also helped to reduce infrastructure costs and improve resource utilization. Yes, it's a very great something. So looking at the points here, honeypot has actually evolved. Yes, it has changed how things were previous because at first there was nothing like this system which is acting as the decoy now is. So so I'd like to talk about techniques and challenges in the honeypot. So first of all, we have balancing realism and security. So presenting a fake environment or data to attackers to actually detect and analyze their behavior. We have baiting. It offers attractive targets or or data to lure attackers into the honeypot. Yes. So let's first of all look at the point one, which says balancing realism and security. So ensuring the honeypot is realistic enough to attract attackers without compromising security. So you actually have to make sure that the honeypot looks kind of attractive to them without trying to take out the fact that there is security at hand to be dealt with. So secondly, we have managing false positives and negatives. So handling false positives and negatives and ensuring accurate threat detection. So sometimes the system can actually give a false alert. It can actually alert you and then you go and check and then there's nothing there. It's just a system issue. An issue that it's not an attack. So our next point is ensuring data quality and integrity. Maintaining accurate and reliable data for analysis and threat detection is a very good technique because anytime the data is being transferred and then the honeypot is acting as a trap, you should actually be able to make sure that the data being sent is still that data and then the attackers are not even close to getting the actual sensitive data which is being transferred by that. Let's take into consideration the kind of things being sent over a very huge network. Yes, we should take that into consideration when talking about integrity here. So even though the honeypot is trying to serve as a mask on the real on the sorry, on the real system, data being sent should actually be very, 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 very secure. And yeah. So our next point here is addressing ethical and legal concerns. This very point is let me say vital, is because anytime these honeypots are being set, there are some rules. Yes, the person who actually sets it should go by these rules and should go by them. Skip them, the system can can be a subject to legal prosecution. Yeah, right. So next, yes, as I said previously, there are ethical and legal consideration in honeypot deployment. So our first point here is informed consent and transparency. So yes, first of all, you should clearly disclose the presence of a honeypot in the system. You should always make it known. Yes, make it known that there is a honeypot, but not known to your attacker. Yes. So secondly, we should also provide transparent information about the purpose, scope, and functionality of the honeypot. Thirdly, we should get informed consent from the users and attackers before collecting and analyzing their data. So after they try to attack, we should have to take the data being analyzed by the honeypot in the logs. Should take them and then try to analyze them, find the functionality of it before releasing it out for people to know how the attackers actually work. Because we shouldn't forget that the main aim of trying to set up a honeypot is to know how the attackers attack, so that we can actually create a solution, or let me call it a remedy, to how they attack. So our next point is data protection and privacy. So we should also ensure that there is CIA, yes, confidentiality, integrity, and then availability in terms of collecting the data. Also, we should protect personal data and then also maintain the anonymity of attackers and users. So those using the network should be anonymous. Yes, they should be anonymous. They shouldn't be known. The attacker should also remain anonymous. Yes. So this is some of the legal considerations before trying to deploy a honeypot in the cloud. For that. So secondly, we have compliance with laws and regulations. So you should also familiarize yourself with relevant laws, regulations, and standards such as we have CFAA, yes, I'm sure CFFA, sorry for that, computer fraud and abuse. You should know these laws very well. We have the ECPA, yes, ECPA, Electronic Communications Privacy Act. This is actually an act that talks about the privacy of like electronic gadgets when it comes to their communications. Thirdly, the GDPR. GDPR is very, very, very important because it also looks at the CIA and all those other things. So these are laws you must comply with. They are laws you must always check that I am actually following before you try to deploy a honeypot in the cloud. So we should also avoid entrapment and coercion. We shouldn't try to entice or coerce attackers into engaging with the honeypot. Should also ensure that the honeypot is not used to induce or encourage illegal activity. This honeypot shouldn't be something that should do anything illegal. It should have a legal purpose, else it can be brought down by any other individual which thinks it is unfit. Yes. So we should also maintain a clear distinction between legitimacy and illegitimacy. So anytime you are trying to have any illegitimate act, it should be, let me say, be considered as such. Anytime you are trying to have a legitimate activity, it should also be considered as such because when you are caught and you are being dealt with, a judge should actually know that this that you are doing was a legitimate intended purpose or an illegitimate intended purpose. So these are things you should actually consider before trying to deploy a honeypot in the cloud. You can use AWS. My colleagues will mention that in the upcoming slides. So we have AWS and Microsoft Azure. These are all cloud platforms that you can actually deploy your honeypot clouds onto. So let's go to the next slide, which is honeypot in cyber attack identification. Yes, honeypot has actually done well in cyber attack identification. This very feature is has done something. So first of all, we have early threat detection and response. So anytime there is an attack, the logs and everything tends to tell the user that there is a threat. It detects it, and after it detects, it gives response. So early threat and detection. Yes. So our next point is improved incident response and remediation. Yes, improve incident response and remediation. So you see, because the system has been able to learn from the previous task, it will be able to know how to maybe come about any form of attack that comes. So the incident response will what improved. The user will also know that okay, attackers can actually use this very channel to attack. So why don't you rather find a way of trying to actually fix that thing before it comes? Yes, so that's one point. Second, thirdly, we have enhanced threat intelligence and sharing. So honeypot has actually helped to enhance threat intelligence. Yes, that's actually helped to enhance threat intelligence and sharing. So honeypots they actually provide valuable insight into threat actor behavior, helping a lot of organizations to actually understand their adversaries. So TTP analysis, this very thing actually helps honeypots reveal the attackers' TTPS, enabling organizations to actually develop targeted countermeasures. So this TTPS helps the organizations to know how to actually counter. Yes. So the fourth one is reduced attack surface and risk. So reduce attack surface and risk. So identifying vulnerabilities. Honeypot helps identify vulnerabilities and weaknesses, enabling targeted patching and remediation. Yes, very, 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 very necessary. So honeypot will first of all identify the vulnerabilities, weakness, and everything in your network, and then tell you where to patch. They kind of give you a remedy to some problems in your system before actually giving you problems being raised by attackers when they are trying to break through your system. Yes. Let's move to the next slide. We have models for successful honeypot deployment. So first of all, we have the virtualized honeypot environment. So this is a virtual environment for a honeypot. Yes. So the virtualized honeypots provide isolated environments for attackers to actually interact with, reducing the risk of compromise to production systems. So anytime it is rather in a virtual environment, there is a low risk which is to the main production system. Also, virtualized environments give a scalable sort of something. Let me see. The virtualized environment can be easily scaled. You can enlarge it, reduce, do anything you want to do with this, just to accommodate the landscape, the landscape. Yeah. So the next one is hybrid honeypot approaches. So with the hybrid honeypot approaches, it actually it combines passive honeypot. So the hybrid approach combines the benefits of the active and the passive honeypot, providing a more comprehensive threat detection solution. So it doesn't just use the passive or the active, it just combines the passive and the active. As it combines these two um, honeypot environments and then uses them to learn and then detect threats. So it also integrates with existing security tools. Yes. So if the tools are there, it just integrates with them. So it just uses them interchangeably. Yes. Next point is cloud-based honeypot solutions. So with the cloud-based and honeypot solutions, they are they are actually scalable. They can accommodate changing trade landscape as well. They are cost effective. Yes, they are cost effective. They are actually usually sorry, they are usually more cost effective on premise than on cloud. Also, they can be easily deployed. As you all know, cloud, when it comes to cloud based stuff, they are easily deployed. It's just easy to do. So that's one thing we can say about the cloud honeypot solutions. Also, let's talk about open source honeypot platform. Open source honeypot platform, on the other hand, are often free or low cost. Yes, they actually reduce the financial burden. So the user doesn't really have to spend a lot. Yes, doesn't have to spend a lot when it comes to the security aspect. Yes, you don't have to spend a lot. And then also it is community driven. That's one very key point we should always remember about open source. Because open source, anytime we hear of open source means free. It's open source, the source is open. Anyone can get access to it. So it is cost effective. As I said earlier, community driven, everyone can use it. It is customizable. You can go there, customize anything you want, try to change it to actually suit what you need or what you want. Yes. So the next one, we have economic benefits of honeypots. Honeypots, they have reduced costs associated with cyber attacks. So honeypots here, their cost is actually low. Was looking at the kind of effect an attack will have on the system to the cost it is actually giving you to keep that system secure. You can see that here it actually pays. It pays off. It pays. Yes. So next one we have improved incident response and remediation. So the honeypot actually improves and it improves how the user will actually respond to an incident, and it gives the user a remedy, like sort of a solution to some of the attacks. Also, it has enhanced threat intelligence and sharing. I explained this point earlier. The next one is increased confidence in cybersecurity measures. So honeypot gives the cybersecurity measures, which are knows on the cybersecurity measures, it's actually increasing the confidence in them. So we have measures like maybe um, encrypting, all those kind of measures, how to keep your data safe. So it makes room for them, as in making them thrive. Yes, let me see that one, making them thrive. So next, sorry. Yes, this is very, very, very important. Without this, you can't actually know how to monitor cyber attacks. So first of all, we have threat detection and response. I've said it several times. Threat detection and response. So the honeypot detects threats and then responds to the threat. Yes, the honeypot will detect the threat and then respond. That is the first part. Secondly, it will give a response. Yes, it will give a response and then give a remedy to the attack. Also, it will keep track of how the attack has been done, which is threat intelligence and sharing. So it will actually keep track of how the attack was done, know how it was done, learn from how the attack was done, so that in the near future, in case a similar attack comes up, the system will know how to go about it. Yes. So our next point is continuous monitoring and improvement. So after it has come to learn about how to go about those attacks, it will actually continuously monitor. First of all, detect threats, incident response and remediation, threat intelligence and sharing, and then continuous monitoring. So to keep on monitoring to actually see if there will be any other attack. If there is any other attack, it will also inform again, then the whole thing starts again. So these are the processes involved in monitoring cyber attacks by honeypots. So in conclusion, all I have said here is honeypots, and I said honeypots is a decoy, or let me call it a trap that actually detects threats and then informs the one who set that trap for the attacker. It's also learned from the system. It learned from how the it's so it learned from how the attacker attacks. It learns from it, and then it also gives like sort of a solution to how to go about it. So it learns from it so that next time when that attack comes, it can actually solve it without having to go back and go through all those stress it's going through the first time. You just learn from it and use it to solve further attack. So my group member will actually take over from this point, and you explain further, and then there will be a point where you will have to watch a video on how to actually set up a honeypot, deploy it, how to use you get to know about the Kibana. And we have the teapot, which is the main type of honeypot which will be used in trying to set up this whole honeypot something. Yes, so I would like to end here. Thank you very much. Have a wonderful day.
I'm Serum Sisavi, presenting on the task 3 for the honeypot interaction medium configuration. With the design objectives for the honeypot configuration we did, there are some bulletin points we highlighted, such as simple and low-risk design, early alarm systems, and research tools, with which I would like to talk about per our research on how to go about it during our honeypot configuration. The simple and low-risk design of the honeypot is to create a honeypot that is straightforward to deploy and manage, with minimal risk to our actual network infrastructure. This involves choosing a design that is not very complex and reducing potential points of failure or vulnerabilities. In our practical exercise, we chose low interaction honeypots that mimic essential services like HTTP and SSH. We used minimal configurations and restricted the instructions to ensure that even if an attacker attempted to exploit the honeypot, they would not be able to gain access to the raw network. Moving on to the early alarm system methods, which we did. The early alarm systems, first of all, of the honeypot acts as a warning system, alerting security teams to potential threats before they reach critical systems. This allows for a proactive response to incidents rather than reacting after damages has been done. In our configuration exercise, we set up the honeypot to monitor for types of traffics such as suspicious SSH login attempts or unusual HTTP requests, which these were detected. The honeypot immediately logged the activity and sent alerts to our monitoring system, which led to the early detection and allowed us to investigate and mitigate threats in real time. With the research tool in our exercise, we captured and analyzed the data from various attack attempts on the honeypot. This data included information on the IP addresses of attackers and tools they used in the methods they employed. By analyzing this data, we were able to identify some common trends and adapt to new security measures accordingly. Moving on to the network topology of the honeypot system. The honeypot system plays in a DMZ for our practical work ensured that it was on a separate subnet from the rest of the network. We use firewall rules to limit its access to critical network resources, whilst allowing it enough access to stimulate a raw environment and interact with potential attackers. With the separated from production network, one would say that it is the risks that the honeypot goes through in order for us to be able to isolate it from the production network. This separation ensures that the honeypot is compromised and the attacker cannot easily access its critical systems or data. In our configuration, we ensure that the honeypot was connected. Continuing with the conclusion for our honeypot configuration, in our practical, we've learned that with configuring a honeypot, it involves selecting the interaction level and services to emulate, typically using a virtual environment for its flexibility. The honeypot is placed in a DMZ, isolated from the production network with controlled internet access to external attacks. The key services in the honeypot configured are to mimic raw systems with docking and alert setups to capture and analyze data attack. Security measures like strict firewall rules and regular patching protect the honeypot itself from attacks. And then once our honeypot is deployed, the honeypot is continuously monitored, providing valuable insight into threats while keeping the actual network secure. Thank you.
I'm David Mensah, and I'm come to continue from where my colleague stops. So today we are going to talk about the early alarm systems. So let's break down the process of using a honeypot to detect a zero-day exploit. So the first point is honeypot detects unusual activity. A zero-day exploit targets a previously unknown vulnerability, so it often behaves differently from known attack patterns. The honeypot might notice unexpected demands or data being sent. So the next point is alert security teams. When the honeypot detects something suspicious, it immediately notifies the security team. And the next point is quick response and remediation. The security teams sprint into action. They analyze the data from the honeypot to understand the exploit. They also identify the system that might be vulnerable. So let's continue to the next one. Research tools. The research tools are going to talk about the analyzing malware behavior. The first point is honeypot data capture. The honeypot collects data on the malware's actions, including infection method, communication channels, and payload. The second one is data analysis, or the research analyze data. Researchers use various tools and techniques to analyze the captured data. So the last one is insight into malware behaviors. So insight into malware behaviors. The analysts provide insight into the malware behavior, such as how it spreads, evades detection, and targets specific systems. Well, let's continue to the next one, that is specification and design options. The specification and design options allow for easy reset and reuse, enabling consistent testing without physical wear or tear. So the first one is open source software, cost effective and customizable, offering flexibility and control over the system. And the next one is simple configuration. In the simple configuration, easy to maintain and update, reducing the time and effort required for system management.
Good evening. My name is Henry Ryan, and I'm here to talk about the prototype implementation, like a cloud-based honeypot using a trusted platform, a cloud trusted platform. And we chose the AWS, the Amazon Web Service, as the cloud trusted platform. When we talk about the reason why we chose the Amazon Web Service is that they are scalable and secure. When we talk about when AWS is scalable and secure, we are talking about AWS is providing a platform that can easily scale to meet demand while meeting a strong security protocols, making it suitable for deploying a cloud-based honeypot. And it also supports various operating systems like Amazon Web Service supports multiple operating systems, offering a flexible in choosing the right environment for your honeypot. And some of the operating systems we have the Ubuntu, the Fedora, the Kali, there are many. Okay, AWS is also cost effective. When we talk about cost effective of AWS, pricing model allows you to pay only for the resource you use, making it affordable solution for deploying honeypots. Okay, let's move on to the selected tools. We related out some tools that we are using the teapot. The teapot is a multiple honeypot. It's a multiple honeypot platform that includes various vulnerable services to attract and analyze cyber attack. The Kibana also talk about the data visualization to the help. Also talk about data visualization that help in analyzing and also visualizing the attack data collected by the teapot. Elasticsearch is a powerful data storage and indexing system that stores and manage the data collected from the honeypot for efficient searching and analyze. Okay, let's move on to the configuration options. You can choose virtualized environment and open source configuration. Talking about virtualization environment, the honeypot will be deployed in a virtual environment, allowing for ease management and scalability. And also on open source software, the use of open source tools like the Teapot, the Kibana, and the Elasticsearch help us to reduce the cost and also provide the transparency in the setup. The simple configuration, the selected tools are straightforward to configure, enabling a quick and efficient step process. So okay, let's move on to the Teapot configuration. So when we talk about the Teapot configuration, service emulation, the Teapot is configured to emulate various network services like the SSH, the HTTP, etc. like their minimum to attract different types of cyber attack. Network configuration, a proper network setup is required to direct potential attack traffic towards the honeypot. Logging options, Teapot provides extensive logging features to capture the detailed information about the attackers. Okay, further analysis. The Kibana configuration is also talk about data visualization. Yeah, also talk about the dashboard setup. So the dashboard setup Kibana allows you to create a dashboard that will visualize the data collected by the teapot, helping in the real-time analysis of the attack pattern. I would say search and filter options. Yeah, okay. The Kibana provides tools to search and filter through the data, making it easier to find specific information and also related to attacks. Okay, let's move on to the Elasticsearch configuration. When we talk about the Elasticsearch configuration, data storage, Elasticsearch is used to store the logs and data generated by the teapot, ensuring that all information is organized and easily accessible. Index setup. The indexes in Elasticsearch are configured to efficient, organize the stored data, enabling quick access. Search and filter options. The search and filter. Search and filter options. The Elastic also offer a powerful search and filter capabilities to retrieve relevant data from analysis. Configuration setup. Create an AWS account. Set by creating an AWS account to gain access to the cloud service needed for the honeypot setup. Set up an EC2 instance. An instance on the AWS to serve as the host for the honeypot. Also, install and configure Teapot. To install and configure Teapot, to install the Teapot honeypot software on the EC2 instance, and also configure it to start capturing attack data. What else? Install and configure Kibana and Elasticsearch. Set up a Kibana and Elasticsearch to virtualize and manage the data collected from the Teapot. Acquiring quantitative data. The attack frequency and duration. Attack frequency and duration, whether how often the attack over and how long they last. Okay. Attack vectors and techniques. Attack vectors and techniques. Let's talk about the different methods and techniques used by the attackers against the honeypot. Attackers' IP addresses and locations collected by the analyze. Collected. We collect and analyze the IP addresses of the geographical location of the circuit to understand the resource of the attack. And also what? The attacker IP address and location. I think I've talked about that. So I think that's all. By concluding the list of references used in the prototype implementation. Thank you.
So currently I'm in the Amazon Web Service home console. Here to set up the honeypot, we need an instance, and then we have to connect the instance to our. We need an instance where the instance we use it to create a virtual system, virtual machine, right? And then we connect that to our Linux, and then we use to set up the honeypot. So let's dive into how we're going to do that. So first, we set up the instance. We go to the EC2 management console, the dashboard. So over here, we see options, but then we are here to launch an instance. So go to launch instance. So when it comes name and tags are instance, we have to give it a name. So I'll just name my group work, right? Group work because it's a group work. And then we need OS, right? An operating system for our virtual machine, the instance we're creating. So I'm going with Ubuntu. So at here the instance type, and I'm going with t3.xlarge. You can also go with the t2.xlarge, right? And here we need a key pair that we're going to use to log in a Linux terminal, right? So uh, we can just give it any name, right? So I can just give it JB, or they said JB already. I can just give it um, maybe USA, United States. Yeah. So use key pair. So USA, you have USA here. So and then from there we give it a storage, right? I'm going with 128 because my phone is 128, so I just have to go 128. So here we are done. We're done with everything 128 storage, our keep USA, and the instance type, and Ubuntu, if we are going with, and the name, which is before. So launch instance. So to dive into the instance, we click on this, and this is the instance group web, the ID, the state of running, and the type. Yeah, so let's see what's inside. So over here is the instance, the details of our instance. Yeah. Now here, let's go to connect. Right. Over here, I'm at SSH client. There's EC2 instance connect session manager, but this is where my interest is. So here they are saying open an SSH client, the keeps a private key file, use this to launch the instance, and then run this to ensure your key is not uh, publicly viewable. And then you connect your instance to this VLS, right? So this is what we are going to use to uh, log in or connect, however. So let's go to terminal, and I was already working here, so let's clear everything. Now we're already in our downloads uh, directory. It's here, download. So there's no need for us to, open downloads again, right? So let's see what's in the downloads directory. And so we have this, and these are things that are already created already. But for the sake of this video, we will use the USA, right? Yeah. So to do that, we do chmod 400, like we saw on the page, like we saw here to locate the private key file. Right? So we have to run this command to ensure that it is not publicly viewable, right? So like this. So go back to the terminal and chmod and then USA.pes, right? And then the user will copy this one. Yeah, the whole of this. We're going to paste it there. So we're going to paste again. You don't need that. So are you sure you want to continue connecting, connecting to this? Yes. So we are done connecting. We have to upgrade the instance. To do that, sudo apt dot update, and then we wait for it to finish updating, and then we do something exciting. So it is done updating. So we upgrade it. So sudo apt upgrade. Do you want to continue? Yeah. So we wait for it to finish upgrading. It should be in a few seconds, 1 minute time. Okay, now that it is done upgrading, the point of this video is to set up the honeypot. To do that, we need a teapot C, right? So we need teapot, and the teapot we get it from GitHub, right? Normally, we have to install GitHub first. If this OS was a different one, maybe Kali, right? But Ubuntu comes with GitHub already. So for that reason, we'll skip the installation of the GitHub part, and then we'll just go straight to cloning the teapot CE, right? And we'll do that by, first of all, before I do that, let's do this. Clear, so let me start everything on a new fresh page, right? So, so git clone https colon dash dash github.com slash what was it called, telecom slash security slash t dot ce dot git. Why did we do this? This is the URL to get the teapot, because if you come here and you type github dot com slash telecom security. Right? Yeah. So this is the T.ce. This is it. This is it. This guy. This guy. This guy. So this HTTP double forward slash github.com.telecom security slash this guy means we want this guy. So let's go back. Yeah. No, sorry. I was a mistake. Terminal. Yeah. And yeah. Enter. So this is going to clone. Clone means duplicate or something like that. So this is going to give us a form of the same thing but just in our terminal in our main OS, right? So now that is done, let's see. So we have it there. We have it there, T.ce. And we have CD and then T, but that's to go inside this, to go inside this. That's why you're typing this. So we are in, and let's see what is inside this to display. Good. So now we need to install it. We have it, but we haven't actually installed it yet. To do that, we have to dot forward slash and then install.sh. So that install, yes. So this shows that the T.ce is being installed actually. So this is the progress. So let's wait a few minutes and then see how it's going to be like. Currently at 90, about 99, almost there. Okay. Yeah. You still have to wait a few more minutes, just a few. It's actually taking quite a little bit longer. So should finish in that. So here you are being asked to enter web username. The web is the honeypot. So the username you're going to use for the honeypot. So I'm using happiness 7. Right. Yes. And password I'll use Hiroshima and Nagasaki. And repeat Hiroshima. And okay, I think I made a mistake somewhere. Good. So we're going to hit the web for us. And now all we have to do is to wait for it to finish. So here all the basic necessities that are supposed to happen before we can have access to our web is happening. Pulling. So yeah, let's wait for our success of. The network is delaying us. Okay, so it is done, and we are being asked to reboot and reconnect via SSH on this port 64295. So let's reboot. Do that by sudo reboot. So now we are back. We are out of the we are out of this directory. The T port. So we are back into the download. So let's clear this so everything can be on the top again. And before we continue, we need to go back to the we need to go back here, add one or two security rules so our uh, honeypot site or web can work. So let's go and add the rules. We go to security first, then you click on this. Then we go to edit inbound rules to add some security rules. I think I'm going to add just two, and I'll change this to custom, and I'll change this to my IP, and this to the port we were given here, which was or which is 64295, right? Because this is the port we are using to connect from the terminal. Right. So this is 64295. My IP, that's the source, my IP. So from terminal. And here, this is going to be the port from the web. From the web. So I'll give it 64297. And this is from anywhere else. And I'll give it a range of six between 1 and 64,000. Right. This is also my IP. And this is anywhere IPv4, right? So save. Okay, let's go back here. Here. Go back to the details of our instance. This. So let's go back to the terminal and see. So ls to see. Okay, so we are actually done with uh, what we have. So we are going to do this. We're going to use this SSH, and then we were told to connect via a port from the previous page before we came. We were told to connect via a port. So to connect via a port, we're going to use minus hyphen p, which means port 64295. Right. Then that's basically it. We've connected it to this. As you can see, we are in. So last login, something. So let me try it on the web. So to do that, we will actually need the IP address of an instance from the web. Here we're going to do https colon forward slash the IP address we just copied colon the port we gave it for the web, which was 64297. So advanced, this is just a warning how we are trying to check if it is working. So the username we gave when we were creating this, which was on Happy Nice 7, and the password was Hiroshima and Nagasaki. Right. So don't say and we are in. So this is actually our honeypot or teapot site. And here is our attack map. Attack map shows where we are being attacked from and the location and all those stuff. Well, basically works like a map. So this is a map, but an attack map. So a map that shows where we are being attacked from. This is our location. This is the location of the server or the server here on which we placed our instance back from here. No, not here. Should be at home. When creating, you choose where the location of your this thing should be. So this is basically it, right? Zoom out. So there's something happening here. Yeah, so this is the attack map. Yeah. So there would be a continuation of this video where I'm going to show how the attraction and knowing how the people are attacking comes from, right? So in the last 20, just now, in the last 1 minute, there's been 11 kind of attempts, I think. Yes. So that is it for this video. I'm glad to have done that for you, yes, Audrey. I hope I hope this will gets to at least a certain level of your satisfaction. Thank you. Hello everyone. Let's see how our honeypot is serving as a tool or whatever to show us the kind of attacks we are receiving and how the attacks are being done and all that, right? So at this place, we are currently in the teapot, which is our honeypot dashboard. And then from here, we can see that the honeypot attacks we are receiving currently is 4,177, and then we have honey trap, which is so basically this dashboard shows the kind of attacks and the number of attacks that are being, you know, attacked on us at this point. So here you have the honeypot attacks bar, the attacks histogram. All this is basically showing the type of attacks and their levels, and then over here you see the operating systems, and over here the attacks by country. There's Brazil, United States, and then if you look here, so far most of the attacks are from Brazil. Yes, from what I have here, most of the attacks are from Brazil. And yes, also here too is attacks by honeypot, which is also given by chat. And over here too we have the username tag club. So this is basically showing us, you see, the attacks that are being done right now. Most of them are, let's see, I think they are honeypot attacks here. So this is just showing us the usernames and the username they are trying, right? This is some of the usernames the people attacking are trying. We have Ubuntu, Oracle, SA, Root. These are what they are trying, and these are also the passwords that they are using. So these are the usernames and the password, right? So yes, these are the usernames they are using and the password they are using for the SSH brute force attempt. So this is a group of them. That's what they are using to do that. And over here, there's the source IP, attacker source IP, top 10 IP addresses of the top 10 attackers we are having, right? And let's go to the teapot attack map. Now, in the teapot attack map, we can see that in the last 1 minute, we've had, well, 4 attacks. In the last hour, we've had 1,918 attacks, and then in the last 24 hours, we have 464 attacks. Now, this is also a map, like an attack map. So, a map that shows the attacks from where they are coming from and all those things. And here you have the event that shows when they happen, the IP addresses, and then the country they are coming from, and then the services they are using, and then the kind of attack. You see, all those things can be found here. So basically, this is how the honeypot works, and it is supposed to, attract people, which it is doing now, and then show us the kind of methods they are using to attack or do whatever they are doing, which I just spoke about from the honeypot teapot dashboard. So basically, this is, I think, what it is supposed to do. Yes, their usernames and then the passwords that they are using for their attacks. Yes. So I think this is how our honeypot is supposed to be working, and then all things being equal, it is actually functioning. Yes. So I'll end this video here, and yeah.